Good morning. Can you hear me?
Good morning, ma'am.
Yeah. So I hope you have most of the contents of this course has been completed, and especially my part I have already completed, and I hope others also have completed their part. So today I would like to discuss maybe one or two past papers so that you can understand how to answer the questions. Mostly students spend more time on unnecessary points, and they at last they tell they do not have enough time. So I want to discuss how to answer only for the point asked. No need to answer beyond the question. Okay, then you can save your time and get more marks. So today I'll discuss one or two papers, past papers with their scheme so that you can have an understanding. So before that, before going into the paper, I would like to tell about this. I have already given to you as a handout. What are the learning outcomes of this course? Okay. So you have to concentrate in this. Learning outcome means what you should be able to do at the end of the course. So first learning outcome is compare the different physical, chemical and biological properties of the soils. So we have studied many physical properties, chemical properties and biological properties. So you should be able to compare them. So if you are asked to compare, you have to tell the similarities as well as the differences between two aspects. Okay, and discuss the influence of different factors on each soil property and processes. So you have studied different soil properties and processes, and you have also studied what are the factors that influence those properties. So you should be able to discuss the influence of different factors on each soil property and process. Then recommend appropriate management methods to improve soil properties and processes. So under each property you have studied how to improve that those properties. So for example, porosity or structure, how to improve. A few aspects we cannot improve. Can anyone tell which soil property we cannot change or we cannot improve?
Texture.
Yeah, texture. Any other property? Similarly, any other properties which we cannot improve?
Particle density.
Yeah, particle density also. We cannot improve unless we add a lot of organic matter, because in particle density ms over ds, so in the ms even the weight of organic matter is influencing, but normally we cannot influence particle density as well. Okay, except those, most of the other physical properties we can improve by management practices. Similarly, for each and every property you have studied how to improve them or how to manage them. So you should be able to tell them. Then analyze all properties and processes. So that is as far as practical is concerned, that you should be able to do. Then derive relations among soil properties. You have studied to get some equations, derive some equations. For example, can anyone tell what kind of equations you studied to derive relation among properties? Deriving some equations. Can anyone tell an example?
Porosity.
Yeah, porosity. What are the properties related to porosity? Porosity.
Particle density, bulk density.
Yeah. Any other equations you studied? Yeah, weight ratio, particle density, bulk density you studied, and also a relation between weight ratio and porosity also we studied. Okay, so those kind of deriving of relationships you should know, because the questions it is here, the clues are here. Okay, then calculate different aspects related to soil properties. So maybe a few things, if you are given few properties, you should be able to derive other properties. Okay. Then interpret analytical results of soils. So that is mostly related to practical. So if you are given any titration value, you should be able to calculate and interpret. Okay. Then appraise potential of different soils. Appraise means evaluate potential of different soils. So maybe you will be given some data and you will be asked to evaluate in terms of different aspects, evaluate the properties. Okay. So that is the learning outcome and how you use that learning outcome to your examination. Okay. So in compare, maybe you should be able to define each and every property. Compare means if you ask to compare two properties, you should know the definition first. Okay. So that those are the aspects you should be able to do, or you should be able to answer. Okay. So with that. I'd like to move on to a past paper, maybe uh, the past paper of your senior batch, but that is somewhat different, this past paper, because it was held in online mode. So they had only three questions, answer only three questions out of four. But in your case, you have to answer five questions out of six. Okay, because they had a online quiz also for this exam. So only three questions they have to answer. But in your case, you have to answer five questions. Um, are you able to see the screen, the question paper?
Yes, ma'am.
Okay. So this is the, I think, yeah. So the first question was. Um, Copy the following table and fill the blanks using following words. In a row, each word should appear only once. Okay. I think yeah. So here, the texture data is given for soil A, B, and C, and cation exchange capacity using high, medium, low. You have to fill in. Okay. So that is very simple. If you know, if you understand what are those, it is very simple. So can anyone tell cation exchange capacity?
Low,
Yes, soil A low, B,
medium, and C soil high.
yeah. So any other person, can you tell what is the reason for this? Why you are putting soil A low and soil C high? Any other person?
Clay soil have high cation exchange capacity.
Yeah. So that is very simple. Then leaching of nutrients, where it is high.
A is high,
A is
medium, C is low.
Okay. Specific surface area. Specific
C is high.
Yeah. Medium and A is low. What about hydraulic conductivity?
Soil A is high.
Hmm.
C is
Hmm. What about buffer capacity?
soil C high.
Hmm.
C high.
Okay. So very simple. easily you can take 30 marks. Okay. And two textural classes of the above soils were found as clayey, loamy, and sandy. Match these textural names with A, B, C. So very simple question. So what is A? Which is clay, which is loam, which is sand. Very simple. Okay. Then student says is best for cultivation. Giving reasons, write whether the student's statement is true or false. Soil A is best for cultivation.
False.
Okay, so what is the reason?
Leaching nutrition is high.
Mhm. So which is the best one?
B.
Okay, then how will you write the reason for this? How will you write the reason for this? Because it is 30 marks. So here you are telling leaching of nutrients is high. Okay, so you should not finish the answer with that. Okay, you have to compare with other soils also. Okay, so maybe first you have to take cation exchange capacity. So cation exchange capacity is will be poor in soil A, but it will be higher in B and C. Okay, and leaching of nutrients also poor in soil. Leaching of nutrients is high, therefore availability of nutrients for plants is low in soil A, whereas leaching is medium in soil B and leaching is less in soil C. And if you take specific surface area also, soil A has less specific surface area. Hydraulic conductivity is high, buffer capacity is also low. So in among all except hydraulic conductivity, all others are poor in soil A. Okay, therefore it is a false statement. Or if the statement is soil B is best for cultivation, what will be the answer? How you will discuss? Is it correct? And how you will discuss? Hmm? If the statement is soil B is the best for cultivation, what do you think? Hmm?
True statement.
Yeah, true statement. Then what are the reasons?
It has a good cation exchange capacity, so the nutrient leaching is low.
Hmm.
It has a high surface area, and it hold more water.
No, hold more water is C, and cation exchange capacity high is also for C. Correct or not?
Yes, ma'am.
Yeah. So how you will answer?
The loamy soil is better to cultivation because the air holding capacity is high in the loamy soil, so the air can reach in the roots easy
No,
to.
no, you have to answer only based on these data. Okay. So maybe cation exchange capacity is high in C, leaching of nutrients is for in all the aspects, soil B is medium. Okay, but soil A, though in chemical properties it is better, in physical properties it is poor. Okay, and soil C, maybe the cation exchange capacity is high, leaching is less, but hydraulic conductivity is poor. Okay, but as far as B is concerned, it is medium in all. Okay, so it has less undesirable properties, but medium in all. Therefore, B is better. So you have to answer like that. Don't bring any other things into here. Okay. So if the data is given and based on the data, if you are asked to answer, you have to answer based on the data only. Okay. Then the next one, two soil samples from site X and Y were analyzed, and the bulk density of these samples for 1.5 and 1.1 gram per centimeter cube. Using the data given in the table below, guess whether soil X or Y has bulk density 1.1. Discuss your answer using each information given in the following table. So bulk density 1.5 and 1.1, and other properties are given here. So which soil is X or Y is 1.1 and which is 1.5. So these questions are different from the past questions because this exam was conducted in online mode. So we know they will try to copy. So we gave question where you cannot copy from the notes. You have to think and answer. Now tell. Hmm? Which is 1.1? Huh?
Y.
Y is 1.1.
Soil Y.
1.1.
1.5.
1.5. Any other answers? Any other answers? Hmm? Any others agree with that answer?
Yes.
Anyone disagree with that answer? Okay, so Y soil Y is 1.5. Hmm? Y soil Y is 1.5. So for which for the answer X or Y, which is 1.5 and which is 1.1, maybe it is 5 marks. For the discussion, more marks will be given. Discuss your answer using each information given in the table. So first information, texture is clay soil for X and sandy soil for Y. So which soil will have low bulk density, clay soil or sandy soil, and why? Hmm? Didn't you study the effect of texture on bulk density?
Clay city have more porous.
More porosity, so bulk density is low or high?
Low. Clay soil has low bulk density.
Okay, so you have to discuss that. Okay, clay soil has more porosity. Because of that, it will have more total volume and therefore it has low bulk density. Okay, then organic matter. Soil X has high organic matter. So, what is the influence of organic matter on texture?
Aggregate soil.
Huh? Okay, one is organic matter improve the aggregation, so it will increase the porosity. That is one. Any other influence of organic matter on bulk density?
When the organic matter is high, the bulk density it is less.
Yes, that already we have told, but why?
If we add organic matter, the porosity is high.
That we have already discussed. Any other? because organic matter also going to give weight for the soil. Okay, so when the organic matter proportion of organic matter is 15%, the mineral matter proportion is less. So the MS also will be less in high organic matter content soil compared to low organic matter content soil. Okay. Then what about depth of sampling? With increasing depth, what happens?
Bulk density also increase.
Bulk density also increase because you have to tell that also, because in the circles there is a root penetration and also microbial activity, so there will be more total porosity is high, whereas with increasing depth the compaction is high, so the total volume is decreased. Okay, so if you can tell those yes, so here you can see the scheme. So here actually in the final question it is student says soil B is best for cultivation. So here soil A has desirable physical properties, but desirable physical properties soil A has. Then what's desirable properties and undesirable properties soil C has. Then but B has medium in all properties, which is best for cultivation. So this much is the answer. Okay. Then for the next question, so soil X has the bulk density of 1.1 because it is a clay soil which has more micropores, and due to that structure formation, macropores also high. Then high organic matter, therefore low density, and surface soils, root penetration and activity of organism are high, therefore volume is high and bulk density will be low. So that is the expected answer. And the other one, differentiate the following pairs: angular block key and subangular block key, gravitational water content and hygroscopic water, field capacity and permanent wilting point, shrinkage limit and upper plastic limit, and silt particles and clay particles. So these are the you have to only differences are asked. Differentiate. So if you see the scheme, so angular block key, all three dimensions, length, width and height are equal, whereas in columnar, vertical dimension is higher than the horizontal dimension. So that is the difference. Then corners are angular or sharp, but here columnar, corners are rounded. And poor drainage, good drainage, angular block key, here poor drainage. Then it is good for cultivation. Columnar is not desirable for cultivation. And angular blocks are found in normal soils. These are found in salt affected soils. And any 4 points into 5, 20 marks. And so if you ask to differentiate, better to put it in a table form rather than writing in paragraph. Okay, it is easy for us also to correct, and for you also it is easy to write. And no need to draw these lines, just 2 columns and you put number and you can write. Then capillary water and hygroscopic water. So first you have to define them. This capillary water, water held within the capillary pores of the soil. And hygroscopic water is water absorbed on the surface of soil due to adhesive forces. So first, if you just tell the definition, that will be a differentiation. Then capillary water is available to plants, whereas hygroscopic water is not available to plants. Then capillary water is attracted with less force by the soil surface, whereas hygroscopic water is attracted with more force. So any two is enough, but the first should be there because that is the main difference. Then the next one is field capacity and permanent melting point. So here the field capacity is the definition itself is enough. A maximum amount of water left in the soil after loss of water to the force of gravity. Then the point at which the plant can no longer obtain sufficient water from the soil to meet its transpiration need and permanently wilt. So that is permanent wilting point. Then the other one is this field capacity is available to the plant. Water at field capacity is available to plant, and water at permanent wilting point is not available to plant. So those are the required answers. Then the next one is shrinkage limit and lower plastic limit. So what is shrinkage limit? So it is the boundary between solid and semi-solid stage of consistency, whereas lower plastic limit is the boundary between semi-solid stage and liquid stage. So that is the definition. So if you write the definition itself, you'll get 10 marks. And this is the moisture content below which the soil does not shrink, and this is the moisture content below which soil does not exhibit property of plasticity. And it represents the lowest moisture of the semi-solid stage, and it is the lowest moisture of the plastic stage. So any two is enough. Then the next one is silt particle and clay particle. So first you should define the size of those both particles. So clay particle is less than 0.002 millimeter, and this is 0.0022 to 0.02 millimeter. So that is the difference. Then there are more differences. Soil particles they do not exhibit any colloidal properties, whereas clay particles exhibit colloidal properties. Then you can compare the other things, surface area, nutrient retention, cation exchange capacity, you can compare. And hydraulic conductivity variation, any 5 points, into 5, any 4 points is expected. Then you will get 20 marks. And the next question is, discuss the effect of soil pH on availability of micro and macronutrients. So that is first part. Second part, differentiate the structure and properties of 2:1 expanding layers liquid minerals and 2:1 non-expanding layers liquid minerals, and discuss the reasons for such properties. So you have to differentiate, then discuss the reasons. Then the third one is define isomorph substitution. And the fourth one is giving suitable equation, explain how cation exchange helps to reclaim sodic soils. So if the first part discuss the effect of soil pH on availability of micro and macronutrients. So can anyone tell what are the effects of pH on availability of nutrients? How you will answer for this question? What are the macronutrients and what are the micronutrients? Studied or not? Yes? Didn't you study this? Soil pH and effect of soil pH. Hmm? So you cannot tell you didn't study. It is there. Here, significance of pH. For each and every nutrient it is given. For nitrogen, what is the significance of how nitrogen is affected by pH? Phosphorus availability, how it is affected. Then potassium, how affected. Calcium, magnesium, sulfur. She did not give about micronutrients, but for macronutrients, it is given. So you should be able to discuss these 3 slides for this question. Okay. Then differentiate the structure and properties of 2:1 expanding layer silicate and 2:1 non-expanding. So what is the structure of 2:1 and expanding and 2:1 non-expanding? What is the difference? Hmm? No one knows? What is 2:1 expanding clay and what is 2:1 non-expanding clay? What is the main difference? Hmm? Are you there?
Isomorphous cut set.
What? What are 2:1 expanding clay and what are 2:1 non-expanding? Hmm? Forgot? What do you mean by 2:1? Or what do you mean by 1:1? What is the meaning of 1:1 and 2:1?
1:1, the Seca tetrahedral combined with one aluminium octahedral.
Hmm. What is 2:1?
2 silicon tetrahedral seed and
Hmm.
1
Hmm.
aluminium octahedral seed sandwiched.
Okay. Then what is the difference between expanding and non-expanding? So both are 2:1. So in that case, no difference. But what is the difference between expanding and non-expanding?
Isomorphous substances are present in the 2:1.
Mm-hmm. Then what happens? Why that is expanding and this is not expanding? How many types in 2:1?
3 types.
Okay. Expanding, limited expanding, and non-expanding. So what is the difference between expanding and non-expanding? Why 2:1 non-expanding is not expanding?
It has between the layers there is a weak oxygen bond.
Where?
Therefore, it's
Non-expanding or expanding?
in expanding type.
Hmm. Hmm. Okay. In non-expanding, what is there in non-expanding? Hmm? A lot to study, huh? So here it is 2:1. I think the question I have modified later, 2:1 and 1:1. Okay. So in 2:1, 2 silica tetrahedron and 1 aluminum octahedron, and 1:1, 1 aluminum octahedron and 1 silica tetrahedron. Then here loosely held and here hydrogen bond. Okay, 1:1, there is strong hydrogen. Then property high degree of plasticity, stickiness, do not exhibit plasticity. Then surface area, this is high in 2:1, here surface area is less. And cation exchange capacity is high, and here cation exchange capacity is low. And white cracks form in 2:1, whereas here no cracks are formed. These are undesirable for construction. 1:1 are suitable for construction. And also isomorphous substitution is high here. Okay, so first 6 points for 8 marks, and any additional point 7 marks and 55. Okay, so that is the difference. So you should know the differences between different types. So if it is 2:1 expanding and 2:1 non-expanding, the differences will be here. Yeah. Instead of this oxygen-oxygen linkage here, for 2:1 non-expanding, there will be potassium ions in between the two layers, and the potassium does not allow the layers to expand. It will hold the two layers. That's why they are not expanding. Okay, and these also maybe almost similar, but cation exchange capacity is somewhat medium in 2:1 expand, 2:1 non-expanding, and maybe other properties are almost same for both. Okay. Then define isomorphous substitution. So what is isomorphous substitution?
Replacing cation element for others without disturbing structure and some change. Same charge and similar weight.
Replacing cation where? Where replacing cation? Replacing cations where?
For main cation.
Huh? Any other person?
Replacing one element in the aluminium tetrahedral sheet
To reclaim acid soils. So can anyone tell the example? Cation exchange help to reclaim acid soil. So to reclaim acid soil, what we apply? In the uses of cation exchange reactions, you studied this. Reclaim acid soil or reclaim alkaline soils. So to reclaim acid soil, what we apply?
lime material.
Yeah. So here already answer is given in the question. Giving equation explain how cation exchange helps to reclaim acid soil. So this is the example: acid soil, hydrogen saturated collide. So lime, you apply lime, calcium is there, and hydrogen is moved to the soil solution, and calcium is attached to the colloid. Okay, then you have to leach. So if you draw this diagram, that is enough. Okay, so apply lime to acid soil, calcium from the lime exchange the hydrogen, and this hydrogen should be leached. Okay, so for equation 5 marks, and for the text which you write here 5 marks, total 10 marks. Okay, then next question is discuss the effect of different factors on organic matter content of the soil. Then discuss the beneficial effect of earthworms on soil. Then mention the reason why termites are not considered beneficial as earthworms. So can anyone tell different factors on organic matter content? What are the factors that affect the organic matter content of the soil? Okay. So those are the climatic factors. Any other factors?
Topography.
So here discuss. You have to tell each and every factor, and you have to discuss because it is 40 marks. So you have to discuss each and every factor as well. Okay. So if we see, so here the question is different. Describe the effect of organic matter addition on properties of soils. Okay. So this is this effect of organic matter on properties. The other question is what factors affect organic matter content. Okay. So here effect you have to discuss about each and every effect. Effect on color or physical property, then effect on chemical property, then nutrients, then that is the answer for that question. But if you are asked what are the factors affecting the organic matter content, the climatic factor, in climatic factor you have to discuss about temperature and maybe rainfall. That will affect the organic matter, how organic matter content is affected. Then maybe management practices also will affect the organic matter content. Then microbial activity of the soil, temperature of the soil, higher temperature will deplete the organic matter content. And so whatever factors, any other management practices with the addition of any organic manures, all those factors you should answer. Okay. Then the other question is discuss the beneficial effect of earthworms. So you have studied many beneficial effects. So you have to answer all the beneficial effects. What are the beneficial effects of the cast, and what are the beneficial physical effects, then how nutrient availability improved. All these you should write because the marks is 60 marks. And mention the reasons. So I think this is a scheme of another scheme I have opened. Mention the reasons why termites are not considered beneficial as earthworms. Can anyone tell why termites are not considered beneficial?
Because of the rapid development of the nest, they can disturb the crop production.
Okay, any other? Because termite mounds will take the productive land and therefore in some areas we cannot cultivate. That is one. Any other? What about the organic matter content? How organic matter content will be influenced by termites? Hmm? So termites are very heavy feeders of organic matter. So they quickly deplete the organic matter from the soil. Whereas earthworms, they expel the cast and they help to improve the organic matter content. Whereas in termite soils, the organic matter content is less compared to earthworm. Okay, so these are the two reasons. One is they physically they are disturbing the activities in the field, and also they do not have a beneficial effect as earthworms, and they do not improve the organic matter content in the soil. Okay, and those are the reasons for why termites are not considered as beneficial as earthworms. Okay, and maybe I'll show you another question paper of the previous batch. So here you have to answer 5 questions. So for you also like this, 6 questions will be given and you have to answer 5 questions. The first one is describe the composition of soils indicating 2 functions of each component in plant growth and environmental regulation. So what are the composition? What are the composition of soil? Hmm? Composition. What is the composition of soil? Soil is made up of what? Hmm?
Soil air,
Hmm.
soil water, organic matter.
The soil particles are the mineral matter. Sand, silt, clay particles are the mineral matter. So what are the function of that solid mineral matter? What are the functions? Okay, provide nutrients. What else? Provide anchoring or physical support to the plant. Okay, right? And also they only provide aeration or the space for aeration and water content. Everything is provided by the solid particles. If solid particles are not there, these are also not there. Air or water cannot help. What about organic matter? Organic matter, 2 functions. Hmm? Go and study. List any 5 soil physical properties and define each of them. So any physical property, that's a simple question. Then discuss the influence of soil texture in physical and chemical properties and cultural aspects. So that also you can tell. But then what physical properties are affected by soil texture, chemical properties and cultural aspects. So everything is in the notes. So this is again almost a similar question. Then describe one direct method, describe one direct method and one indirect method to determine soil moisture content. Can anyone tell what is the direct method to determine soil moisture content?
Gravimetric method.
Okay, indirect method,
Neutron scattering method.
neutron scattering method, or any other method you can tell. Okay, what else? Electrical. What? Yes.
Tensiometers.
Okay. Then list the advantage and disadvantage of each of the above method given in. So whatever method you give, you have to tell the advantage and disadvantage of those two methods. Okay. Then differentiate gravitational water, capillary water, and hygroscopic water. So if you just tell about what is gravitational, what is capillary, and what is hygroscopic, then you have to tell maybe which is available to water. So gravitational water is not available to plant, or it is harmful to the plant. Capillary water is available to the plant, and hygroscopic water is not available to the plant. So those kind of differences you have to tell. Maybe you can put a table, 3 column, then you can write the differences. Then discuss the characteristics of soils that can be assessed by different soil color. So using soil color, what aspects can be assessed? What aspects can be assessed using soil color?
Organic matter content.
Then what else? For different colors, what why that color is given to that, or why that color is expressed by the soil. It has been given. Okay, why gray color, why red color, why yellow color, and sometimes gray color. So why the soils are gray in color or glazed color? Why?
Poor drainage.
Poor drainage. And why red color indicate what?
Iron.
Iron concentration. Okay, one thing. Any other thing? What about the drainage? If red color, what will be the drainage?
Good drainage.
Okay. What about yellow color? What is the reason for yellow color?
Soil mottles.
So soil mottles means what? So maybe the water table is rising and dropping. So that's why the mottles are there. And also yellow color is hydrated iron oxides. So maybe the drainage is medium, or it is in the medium aspects of the slope. Okay. And so you should be able to discuss the different colors and what can be told about the soil if the soil is that color. Okay. Name 2 building blocks of layer silicate clays and define each of them. What are the building blocks of layer silicate clays?
Silica tetrahedral and aluminum
octahedral.
Okay, so then you just name them and define them, then you will get 25 marks. Then describe the structure and properties of 2:1 expanding clay and discuss the reasons for such properties. So that is okay. Then again isomorphous substitution and its effect on property of colloids. Then cation exchange capacity. So there is a calculation given here. Okay. So I think you also did those calculations. So study them. Maybe physical properties also there are calculations. So there will be calculations coming because in your ILOs are different from your previous batch ILO. So you will be given more of equations and calculations also. Then suggest 3 methods to improve cation exchange capacity. So you should know that also. Then describe different types of classification of soil organisms, giving examples. So that is the direct question. And discuss the factors that influence the amount of organic matter. Okay. So one thing you should understand, all the questions are within the slides. The answer is within the slides which you have studied. So study them, and maybe for you there will be some critical questions because your ILOs are different. You have to do some calculations, not exactly same as the past papers. Okay. So please study, understand and study. And so if you have any doubts, if you want any discussion, then you can contact. I think we'll have on 17th we will have agriculture chemistry subject for you. So mostly we are planning to do practical only. But if you want, then we can arrange theory discussion if you want. But before that, you should be able to study well and come. Okay. Okay. So time up. So wish you all the best. And please study. I think you have already forgotten everything. You have to study. You can have group discussions. And if you did not understand anything, you can come and talk to us, or you can contact us, and which aspect you do not understand, then we can have a discussion class if you want. Okay. So then we can meet on 17th for the practical revision. Okay. Wish you all the best.